Okay, once again, good evening to one and all. Welcome to day 4 session. Online hands-on training program, data analysis using SPSS. First session, we hang on ANOVA. I'm sure many of you might have used as a part of your research work. We have different types of ANOVAs, one-way ANOVA, two-way ANOVA. We also have different terms, MANCOVA, ANCOVA, right? Now, as a part of this particular session, we are going to discuss about one-way ANOVA. If you refer to the previous class, we have discussed about one sample t-test. We have discussed independent sample t-test. While discussing the concept of independent sample t-test, we have mentioned that we need to have, if you have two variables, one dependent variable, one independent variable, and if you have two groups, we are going to use independent sample t-test. Whereas when it comes to one-way ANOVA, if you have more than two variables, we are going to use one-way ANOVA, one-way analysis, variance analysis. I'm just differentiating between what is independent sample t-test, what is ANOVA, one-way ANOVA. One-way ANOVA is also part of compare means. Okay. Now coming to the one-way ANOVA, it is a parametric test. It compares the means of two or more independent groups in order to determine whether there is a statistical evidence that the associated population means are significantly different. Again, I'm just referring to previous example, that is independent sample t-test. In previous class, we have looked at athlete and non-athlete category as a independent variable. And we have taken dependent variable like the number of miles a person can walk, the person who belongs to athlete category, number of miles he or she is walking. And we compared with athlete and non-athlete category. After completion of this particular exercise, we also did one more exercise as a part of independent sample t-test, that is gender and the number of miles per minute duration. Means here, gender is independent variable, number of miles a person can walk is a dependent variable. Now, here gender or athlete, we have only two categories. For example, male, female, athlete, non-athlete. Now, imagine that you have three categories. I'm going to discuss about as an employer. As an employer, you're looking at your employees, those having good leadership performance skills. Okay, good leadership performance skills. Now, what I'm going to do is I'm going to conduct the data. I'm going to ask each one of them, identify yourself. What kind of sex role type do you have it? Whether it is sex role diffuse, whether it is masculine type, whether it is feminine type, whether it is androgenesis. So we have four types, means more than two groups we have it. We have more than two groups. I'm going to give an example as a part of this exercise. So the point is very simple. When you're doing independent sample t-test, you're having two independent groups. Whereas when it comes to one-way ANOVA, if you have more than two groups, we are going to use one-way ANOVA. Now coming to the data requirements, dependent variable that must be continuous, like interval data, ratio data. And independent variable, it must be categorical. That is either nominal or ordinal data. One can use it. The cases that have values on both the dependent and independent variables. Now, when I take the example, for example, I was talking about as an employer, I'm looking at my employees, how they are identifying themselves with regard to sex role type. We have four categories: sex role diffuse, masculine sex type, feminine sex type, and androgenesis. Now, when I talk about sex role diffuse, it means as a person, as an employee, how you are identifying yourself? Are you associating towards masculine or feminine? Now here, as a part of sex role diffuse, it indicates the person neither belongs to masculine type or feminine type. Means neither strongly belongs to masculine or nor feminine. Whereas when it comes to masculine, means this person identifying himself saying that he is strongly oriented towards masculine sex type. Whereas feminine, the person is identifying themselves as a feminine strong sex type. Androgenesis, it indicates the person is having the characteristics of both masculine as well as feminine characteristics. Now, depends on the person identified himself or herself. The identity, what kind of impact is going to have on their leadership performance or the employee performance. So as an employer, I'm trying to test my employees' performance on the basis of how they have identified the type of sex role type they have it. Okay, so imagine that I collected data. Now my hypothesis is all sex role types employees' performance means are equal. We have four categories of employees: sex role diffuse, masculine sex type, feminine sex type, and androgynous sex type. Means my null hypothesis, all sex role types employees' performance are equal. This is my null hypothesis. Now coming to the alternative hypothesis, at least one means, at least, for example, I'm taking out of four, I'm saying that this is a hypothesis, alternative hypothesis. Sex role diffuse employees' performance means is not equal to the others. It's not mandatory that we have to take only sex role diffuse. Just because I understood the concept, what is sex role diffuse, I'm saying that I'm just framing it as an alternative hypothesis. Sex role diffuse employees' performance means is not equal to the others. That is my alternative hypothesis. Now, with regard to our data requirements, we have dependent variable, that is leadership performance. We have independent variable, that is sex role identity type, how a person is identifying himself or herself. That is independent variable. Now, cases that have values on both the dependent and independent variables. Now, when I talk about leadership performance, as I already collected data, we have already collected data. So we have performance of each and every employees from last 6 months or 1 year. Okay. Similarly, we also have data of all the four types of sex role diffuse types. Okay. Independent samples means the whatever the data you are collecting, it should be the observation that you have it. You are collecting data one time from the employee, and data should not influence the rest of the data. Okay. Independent observation. Random sample of data from the population, normal distribution. Yesterday, we already discussed how to conduct normal distribution of the data, right? And homogeneity of the variance. This is another important feature of one-way ANOVA. As a researcher, you are assuming that variance among all the groups are equal. Means we have sex role diffuse, we have masculine type, sex type, feminine sex type, androgynous. We are assuming that there is no much variance differences among all the four types of sex types, right? We are assuming as this is one of our assumption. No outliers. No outlier means if your data is normally distributed, that is one of the important aspect. Second one, we should not have much deviation. Yesterday we have discussed about box plot to understand do we have any kind of outliers in our data. If you have outliers, how to handle this particular data. Yesterday we have discussed as a part of normality testing of our data analysis. I hope it is clear to you all so far. Is it clear?
Yes, sir.
Yeah.
Yes, sir.
Next. Thank you. Yeah, next. Now, after understanding the data requirements, after understanding the hypothesis, just please open your data set, that is coding book 5. SPSS coding book 5.
Yes, sir. Visible. Sir.
Yeah, okay. Yeah, we have, thank you. We have two variables. That is, if you look at label, we'll clearly understand what this particular label is all about. Leader performance, okay? And this is independent variable. We don't have any data values. Next one, we have sex role type. Now here, I need to understand how I have given coding. We have given 1 for sex role diffuse, 2 for masculine sex type, 3 for feminine sex type, and 4 for androgynous. Okay, this is clear. So this is clear. Now, next one, I need to understand what is my sample. We have around 228 responses. Okay, we have 228 responses. To conduct one-way ANOVA test, go to analyze, compare means. We have option called one-way ANOVA. We have option called one-way ANOVA. Here, leader performance and sex role type. Now, leader performance is going to be dependent list, dependent variable. Sex role type, it is going to be factor list. Okay. Coming to the options, we are assuming that as a part of our one of the assumption, homogeneity of the variance test. We are assuming that there is a variance among all the four groups of sex role diffuse. Okay. Click on homogeneity of variance test. Continue. Now, there are two ways one can conduct one-way ANOVA. First of all, we are going to check it out based on our data requirement. There is homogeneity of variance. Okay, click on OK. Now we have two outputs here: test of homogeneity of variance and ANOVA test. Now, if you look at ANOVA test, our significance value is less than 0.001. It means there is a significance difference between the groups. There is a significance difference between all four different groups. Now, how to read this particular table here? How to read this particular table? Now, with regard to the F value, when you talk about F value is this is the ratio. It indicates that the homogeneity of the variance. If the homogeneity of variance means each and every group, if the variance is the same, the F value supposed to be close to 1. If the variance among all the four groups is equal or very close to or equal, F value supposed to be close to 1. But if you look at our F value, it is 38.478. Means it is greater than 1. It means equality of variance is not assumed. There are differences. And secondly, the p-value also indicates that there are significant differences. How much differences we have? We are going to look at it by conducting post hoc analysis. Now, now how we got this particular F value? Now, we need to see this degrees of freedom. The F value we are getting it if you divide mean square between the groups by within the groups. If you get, we'll get F value score. Next, now in order to understand how much difference we have, for example, we have 4 types: sexual diffuse one, feminine type, masculine type, and androgenesis. I want to know out of these 4 groups, how each group is different, how much variance we have it, the equality of variance. In order to understand that, we have to conduct post hoc analysis. In order to conduct the post hoc analysis, go to analyze, compare means, one-way ANOVA. Go to post hoc. As we are going to compare post hoc analysis, equal variance, we are going to check it LSD, because we are going to compare least square differences. We have a lot of differences among the groups. We are going to check least square LSD, one of the well-known post hoc test. Okay, click on OK. Now just look at the multiple comparisons. As you want to check it, multiple comparisons, we are looking at LSD. Okay. Now here, just please look at this particular data clearly. Here we have 4 categories: sexual diffuse, masculine type, feminine type, androgenesis. Now what I'm going to try to here is, I want to compare each type with other sexual diffuse, each other type of sex. For example, sexual diffuse with masculine sex type. How much difference is there? Now, mean difference is I minus J. Here, I is nothing but sexual diffuse. J is masculine sex type. I'm just repeating again. I'm comparing each type with the other type. For example, if I take only 2 categories, sexual diffuse and masculine type, I want to know how much difference we have it. If you look at it, sexual diffuse versus masculine sex type, we have difference of minus 2.98. How we are getting value? If you go back to our value here, descriptors. Okay. I'm just repeating again. We also have to conduct descriptors. In order to do that, go to analyze. Are you there with me? I'm just repeating the test again. Go to analyze, compare means, one-way ANOVA. While doing a test, we also need to select descriptives along with the homogeneity of variance. If you are having descriptives, you are going to understand what is the mean of each sex type. For example, in this particular table, descriptive tables, one can see that sexual diffuse, we got 3.4. Average sexual diffuse employees, we have 3.4. Masculine sex type, 6.3. Feminine sex type, 5.05. Androgenesis, we have 7.27. Now, if you look at average mean value, we have highest mean value is androgynous, right? And followed by masculine sex type, followed by feminine sex type, followed by sexual diffuse. Means sexual diffuse is having least mean value compared to any other sexual diffuse. Looking at the mean value, one can understand. Now, here, I want to understand how much difference we have to that. For that, we have post hoc analysis. Here, sexual diffuse I means I is nothing but sexual diffuse score. That is 3.4054 minus J. In this particular, as for this particular row, J is nothing but masculine sex type. Masculine sex type mean is 6.3898. If you do it 3.40 minus 6.38, you will get minus 2.98. That is the difference, mean difference between sexual diffuse and masculine sex type difference. Got it? Is it clear? You want me to repeat it again? Is there everyone? Am I audible to you all?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Okay. Now, similarly, how we are checking with the sexual diffuse? Similarly, sexual diffuse and masculine sex type, we are also going to check sexual diffuse versus feminine sex type. Sexual diffuse versus androgenesis. Okay. Wherever you are seeing asterisk mark, one can see that there is significance difference. We have it. Okay. But how much significant difference we have? May know which is having lowest significance difference? Masculine sex type versus androgenesis. If you look at it, it is 0.008. Similarly, if you look at it, androgenesis versus masculine sex type, it is again 0.008. Because our mean value, it indicates that after androgynous, we have masculine sex type is having highest mean value. So this particular ANOVA test help us to understand if you want to compare the means more than two variables, more than two independent groups, two or more groups, one can use one-way ANOVA analysis. Secondly, this not only help us to understand comparison between the groups, it also helps us to understand how much difference we have. One can able to compare, one can see the multiple comparisons with the help of post hoc analysis. Now, let's go back to interpretation part. Is it clear? Any of the part? Is there any clarification is required as a part of the data?
Yes, sir.
We have descriptives, tests of homogeneity of variance. We have ANOVA tests and multiple comparisons. Okay. Now, let's go back to our interpretation part. Compare the p-value to some predefined threshold value. That is, if significant value is 0.05. If it is less than threshold value, we are rejecting the null hypothesis. That is, all sexual diffuse, all sexual types employees performance means are not equal. Means we are here we mentioned equal. We are rejecting our null hypothesis and we are concluding that there are significant differences. And we are not only saying that there are significant differences, we are also saying how much differences that we have. That also we are able to indicate here. As I mentioned in the table, F value, with regard to F value interpretation, you can just take note of it. F value is the ratio of your between group variation and within the group variation. A large F value means between the group variation is larger than your within group variation. This can be interpreted to mean there is a statistically significant differences in your group means. And another important point, if the F score is close to 1, conclude that your hypothesis is correct. If F value is close to 1, we are going to conclude that your hypothesis is correct. But in our case, our F value was around 38. It is greater than 1, more than 1. Means we are rejecting our null hypothesis. So the sample do come from from population with equal variance. If it is close to 1, we are assuming that populations are coming from equal variance, right? If the F score is far from 1, then conclude that the population probably have different variances. I hope now we understood, I hope you might have understood right now what is the importance of F value. Now, to satisfy the assumption of homogeneity of variance, we are looking at Levian's test to be non-significant, right? We are looking at Levian's test is non-significant, that is 0.5. As seen in the Levian's test, if it is greater than 0.05, therefore homogeneity of variance are not assumed. Okay. Now, after conducting post hoc analysis, these are the results we got it. That is, F value is 38.48. It is computed by the dividing the mean square between the groups by the mean square within the groups. Okay. If somebody wanted to explain how we are getting F value, as already mentioned, if you look at our output, is out my PPT. I mean, output is visible. SPSS output.
No, sir.
The one.
No, sir.
Yes, now it's
Yeah, we are getting this 38 because you are dividing the mean square between the groups divided by within the groups. We are getting F value, that is 38.478. If somebody want to write detailed explanation as a part of your report writing, you can just take note of, sorry, it's not. Yeah. F value 38.48 is computed by dividing the mean square between the groups by the mean square within the groups. Secondly, you can also mention what is the performance of the 4 groups. And last, one more comparison, whatever we have done with the post hoc analysis, that is multiple comparisons, that also one can analyze it. But the only thing is, you don't need to explain every cell, every row, as mentioned in previous classes. You can see major trends. You can explain major important findings of your report within 1 paragraph, 2 paragraphs. That's sufficient. If you look at the way how I have written it, some of you can agree with that. Test comparisons revealed that all 4 means were significantly different from each other. Androgenesis employees had significantly higher mean leadership performance ratings. Then I'm also quoting the mean score, the mean value. Then did the masculine sex type, that is followed by the masculine sex type, then feminine sex type, and sexual diffuse. I'm also saying that masculine sex type employees received significantly higher performance rating than did the feminine sex. So I'm not explaining everywhere with all the values. I have taken one time with the one values I have taken. I have explained it. So one can able to complete interpretation of one-way ANOVA test. Is it clear to all? Okay. Okay, then once again, welcome to day 4 session. As a part of the session, we are going to discuss about Chi-square test. Pearson Chi-square test is a statistical test for categorical data. Now, so far, as a part of comparing means, we have used dependent variable as well as independent variable. We also use interval data, ratio data, even categorical data. Categorical data, that is nothing but nominal data and ordinal data. But in case, if rank 2 variables, the 2 variables belongs to categorical data, means either nominal or ordinal. In that cases, one has to go for Chi-square test. It is used to determine whether your data are significantly different from what you expected. There are 2 types of Chi-square test. First one is Chi-square goodness of fit test. Basically, we use this particular test whenever the frequency distribution of a categorical variable is different from your expectations. I'm going to explain this what this particular test is about. It's all about it with the help of the data. Similarly, we have Chi-square test of independence. It is used to test whether 2 categorical variables are related to each other. Now, the point one has to clearly remember that whenever you have two categorical data, that is nominal, ordinal, we are going to use chi-square test. Second important point here is your data is your high this is non-parametric test. So far we have used earlier, whatever we have conducted so far, they are parametric tests. Now we are going to conduct non-parametric test. Okay. Now first one is test of independence of attributes. We are going to apply this particular test of independence of test whenever we have two categorical data from a single population. It is used to determine whether there is a significant association between two variables. Now, coming to the data set, there is a requirement. We need to have two categorical variables and two or more. It's, for example, two categorical variables. For example, I'm seeing as a part of this data, we are going to look at it gender and ICT skill set as a part of the data that I have provided to you. I'm looking at the gender, person belongs to male category and female category, whether it is having any influence on information and communication technology skills, whether gender plays any role with regard to their skill set, right? Now, what happens as a part of the data, we have collected data and we have categorized the data. We have kept it as a low skill set, medium skill set, high skill set, low skills, medium skills, high. So we have ordinal data we have. One is nominal data, that is gender. Second one is ordinal data, that is ICT skill set. Now we have two categorical data, right? Next, independence of observations. Okay, that is one. Relatively large sample size. Another important aspect is the expected frequencies for each cell are at least one. Now we are going to have the table. I'm going to explain what is this particular expected frequencies. Once we complete your tabulation part, one of the requirement is that each cell should have at least one frequency. And 80% of the cells should have at least 5 frequency. Very important feature. Expected frequencies should be at least 5 for the majority. Means nearly 80% of the cells should have minimum 5% 5 frequency. Okay. No group should contain very few items less than 10. No group, we have two groups, right? Like male and female category. No group should contain very few items. Means if you have two groups, male and female, none of the groups should have less than 10 count. Okay. Total number of items should be large, at least 50. Though we are expecting large sample size, minimum large sample size, but at least minimum we should have 50. So these are some of the important data requirements one has to consider before conducting chi-square test, that is a test of independence. Okay. Now, next, hypothesis. Our null hypothesis is respondent's gender is not associated with information and communication technology competencies. As already mentioned, we already have ICT data, but in order to conduct the chi-square test, what I did is I have converted dependent variable metric data into categorical data. Earlier it was metric data. Now I have converted into categorical data like low, medium, high. Means low competencies, medium competencies, high competence. Based on specific level, we can able to make it out. My alternative hypothesis, respondent's gender is associated with ICT competencies. I hope it is clear to all so far. What are the importance of data requirements and what is hypothesis? What is the context that we are going to look at it?
Yes, sir. Clear.
Yeah. Now, just please open your data set. My data set is visible. I hope it is visible to all of you.
Yes, sir.
Yes. So I'm not explaining what spectral data is all about it because in the first class and the day one, we have clearly discussed what is the spectral data is all about it. Here we have statements related to field of computer as well as statements related to field of statistics. And we also have certain demographic variables like gender, age, stream, okay, then education qualifications, and ICT skill set. Now, this is the way I have categorized my data: low, average, high. Okay. Similarly, gender, male is 1, female is 2. It is one of the important tasks for each one of you. Please check it, the coding part, how you have done it. Okay, that is really going to help you when you are about to carry certain activities, because you can't come back in between to check whether you are given 0 for 1 or 1 for, 0 for male or 1 for male, right? Next, go to analyze. Go to analyze. Descriptive statistics. Cross tabulations. Go to analyze. Descriptive statistics. Cross tabs. Okay. Now I'm taking two variables, two categorical variables. One is gender. You can keep it randomly anywhere. Okay. Second one is ICT competencies. Okay. ICT competencies. Are you there with me? Shall we go ahead next?
Yes, sir.
Yeah. Now, coming to statistical part, please click on Chi-square test.
Good evening, sir. Sorry for interruption. So
Please.
why choose cross-tab statistics here? Why you have not chosen explore here?
Why I'm choosing?
Why choose cross-tab? Why you not chosen explore?
Why you not choose explore?
Yes, sir.
Why you want to choose explore? We are doing Chi-square test. I don't know what is your good name. Who is this? Is it Vishal sir?
Yeah.
Hello.
Yes, sir.
I didn't understand your point. You're asking why you haven't chosen it. I'm explaining how to conduct Chi-square test. How you're asking why we're going to for explore?
Because sir, in every point on
Every point. Please go ahead. Continue.
mostly time we choose first explore, then
If you are testing a normality test, you have to go for explore for the testing of normality. Okay. With regard to non-parametric test, you don't need to check your normality of the data. Okay. Got the point?
yes, sir.
Yeah. Yeah. So I'm just repeating again. Go to statistics. Click on Chi-square test. Click on Chi-square test. Click on pi and Karmas. I'm going to explain what it is. Click on pi and Karmas. At the time of explaining interpretation of the data, I'm going to explain it. For example, if you're having 2 into 2 variables, like gender, male and female, okay, and if you have only high and low, or yes or no, 2 into 2 table, at the time you are going to choose pi values. If you're having more than 2 into 2, like 2 into 3 or 3 into 3 into 2, that time you're going to use Karmas value. However, when it comes to commands, we have for the both we are going to take, but at the time of interpretation, we are going to take respective value, whether pi value you are going to take, Karmas you are going to take. That depends on whether you have 2 into 2 table or 2 into 3 table. Okay. So next, click on continue. Click on OK. Okay. Now we got how many variables? Case summary, cross tabulation, and Chi-square test, and symmetric measures. I hope all of you got 4 outputs.
Yes, sir. We got.
Yeah. Now, coming to the case processing summary, we have total sample is 50, right? And we don't have any missing values here. And missing values 0. So it is perfect. Next, with regard to cross tabulation, as you can see here, we have 15 total responses. We have 27 belongs to male category, 23 belongs to female category. And if you look at the performance wise, in terms of ICT wise, we can see that male members having highest ICT competencies as compared with female their counterparts, that is female members. Okay, one can able to see this part. In case somebody wanted to look at it in the percentage category wise, percentages wise, what you can do is we have go to analyze. If you want to have only percentages, go to analyze, descriptive statistics, cross tabs. In statistics, in the cells, we have percentages. Okay, one click on percentages, you'll get the actual percentage. It indicates how your data is reflecting here. Okay, so as per your requirement, you can give additional commands so that you'll get percentages. So this
Can you
particular
repeat
percentage,
again the steps for calculating the percentage?
go to analyze, descriptive statistics, cross tabs. Here we have cells. Here we have cells. In the second middle of the this particular dialog box, we have percentages. Just click on total percentages. If you want to check it row wise, column wise, also you can check it out. But just one is sufficient just to understand differences among the different this particular groups. Click on total percentages. Continue. Okay. Is it clear, madam?
Yes, sir. Now it is clear.
Yeah. Okay. Yeah. Now we can see that we have percentages wise. So this particular percentage helps us to understand while comparing, while analyzing your interpretation part. Now coming to the main part of the our test, that is chi-square test. Our p-value indicates it is 0.489. When we are discussing about cross tabulation, I just mentioned that there are differences between male and female category when it comes to ICT competencies. Means I was saying that compared to female category, male having high level of competencies, ICT competencies, as per the data, okay? As per the data, this is what indicates. Now, when it comes to chi-square test, our p-value indicates that there are no much significant differences. Though female members having high level of competencies than female category, but the difference that we have is not much significant differences. We don't have much, means ICT and gender, if you look at it, there is no much association. Means gender is not playing any major role when it comes to having ICT competencies. Looking at our p-value, that is, it is greater than 0.05. Okay. As our value is 0.489, it is greater than 0.05. It means there is no much association between gender and ICT competencies. That's one. Second one. Is it clear to you right now? Point is clear. Is it clear?
Yes, sir.
Yeah. Now, the second one is the value. I was referring to pi and Karmer. If you're having 2 into 2 table, we are going to refer pi value. If you're having 2 into 3 or 3 into 2, we are going to refer Karmer's value. Okay. That is, both the values are same. There is no much difference. Now, only thing is how to read this particular data. What is 1.69? I'm going to explain with the help of data interpretation. One of the important point I want to tell you here is that as a part of the chi-square test, 3 cells, that is 50% of the cells have expected count less than 5. 50% of the expected count less than 5, we have it. If you look at this particular count, we have our count level is less than 5. We have 4 value, this is less than 5, this is less than 5, right? Let's go back to our interpretation part. I'll explain more in detail. Now coming to the results, as you can see the results here, here we have taken low and ICT competencies and gender wise. This particular table, it indicates that both male and female competencies, both male and female respondents have low competencies and ICT in terms of technology. If you look at low wise, both are the same level. Both are the same level. They're 30% and 32%. Okay. However, most of the male respondents had high ICT competencies as compared to with their counterparts. If you look at the row, there is high competencies. We have 14% male category and 6% female category. With regard to high competencies, male is high level as compared with female category. This one. Next one. Next table, chi-square test. Our p-value is greater than 0.05. Our p-value is greater, means there is no statistically significant association between respondent gender and their ICT competencies on technology, right? That is, both males and females have equal competence on ICT technology. Further, the results violated the rules of the thumb as validity of using chi-square test. That is, no more than 20% of the cells should have expected frequencies of less than 5. If you look at this particular cell, that is particular table, the number of expected the cells we have are less than 5. Means we are violated the as a part of validity of chi-square test here. Okay, this implies that the sample size requirement of chi-square test of independence is not satisfied. So what has to do it? One has to increase the sample size so that the expected count, this number of cells that we got it may improve further if you are going to increase your sample size. If you're not going to increase your sample size as per the current data, whether it's publishers, whether it's people, those are looking at your data, they won't recognize that your data is really valid. Okay, your findings are really valid. So only one option is one can go for extending sample size. Instead of 50, you can have 100. Then you can conduct it. One can go for testing it. Now with regard to pi and Karmas value, as I mentioned it, we are going with Karmas is a way of calculating the correlation in the tables which have more than 2 into 2 rows. We are taking Karmas value 2 into 2. There is now how to read it. If Karmas value is, our Karmas value was 0.169. Okay. Now, as per this particular data, if it is 0.1 or between 0.1 to 0.3, that is considered as the effect is very small. Okay. If it is between 0.3 to 0.5, effect is medium. If it is between 0.5 and above, the effect is very high. As we already mentioned, there was no much association. There was no significant difference. Now our value is 0.169, means our size, that is a very small, medium effect size that we have got it. Okay. And you can also write it as a part of your report writing part. What is the effect size is all about it, how one can explain it as a part of chi-square test.
So I have one question.
Please.
So for chi-square test, like we will have to check first normality test or not? Like,
not requirement. Not requirement, because chi-square test is non-parametric test. Okay. If you're having categorical data, or if your data sample size is very less, we are going for non-parametric test. Okay.
Sir, I collected data for my research. Like my data is on a stress, so I have only 50 respondent. So if I want to check like my respondent are the parents of children with intellectual disability, so I want to check like what the disability have any impact on the stress or not. So will I have to do this chi-square?
See, one thing is when you talk about stress, we have dependent variable, right? We have metric data.
Yes, sir.
Yeah. Now, when you talk about disability or impairment, and the type of impairment, there is nominal data. We have it, right? We have different classes.
Yes, sir. Yes, sir.
Right. Now, that one, in that case, you cannot use chi-square test. If you want to use chi-square test, you should have 2 categorical variables. Either it can be nominal data or ordinal data, right? Now, when it comes, for example, now as you are saying that metric data we have it, but your sample size is 50, and still you can do it. But only thing is, if your data is not normally distributed, you can go with a non-parametric test like we have. Yesterday I was referring to the Mann-Whitney test. We can go for that. Okay,
Actually, my data is normally distributed, sir.
Then you can go with independent sample t-test.
Independent sample.
And for example, how many types of disabilities we have? 2 categories or more than 2 categories?
There's 3 categories, sir. Mild, moderate, and
You
severe.
you can go with ANOVA test, one-way ANOVA.
One-way ANOVA.
One-way ANOVA. Okay. After understanding the concept of quasi-square test of independence, now second one we are looking at it, quasi-square goodness of fit test. Now, what is the difference between first one and second one? Now, with regard to the second one, that is quasi-square goodness of fit test is a single sample non-parametric test, also referred to as one sample goodness of fit test, or Pearson quasi-square goodness of fit test. You can use a quasi-square goodness of fit test when you have one categorical variable. It allows you to test whether the frequency distribution of the categorical variable is significantly different from your expectations. Often, but not always, the expectation is that the categories will have equal proportions. Now, in previous one, we have 2 categorical variables. One was nominal data, second one ordinal data. Whereas when it comes to goodness of fitness test, you are going to have one categorical variable, but it will have some expectations. You are expecting it. You have some expectations value. Now, as a researcher, you have some expectations what is going to happen before testing it. And you are going to check it out. You are going to compare your expectations with the observed value. Means you will look at your expectations with the after completion of the study, what are the observations we have? You will look at it, how it is different from that. Okay. Now, for example, as a part of our data requirements, one categorical variable that is either nominal or ordinal, you should have independence of observations, just like previous test. Okay. And there must be at least 5 expected frequencies in each group of your categorical variable. Means if you are taking any particular table, particular cell, you should have minimum 5 expected frequencies in each group. Okay. Now, example, just imagine that all of you are using SPSS from last 3 days, and many of you are using from so many times. Okay. Now, IBM SPSS wanted to give you some gift. IBM SPSS wanted to give you some gift. Those are purchasing the package. Okay, those are purchasing the package. So they came up with the 3 important types of gifts. One is quick feel software, pen drive, and headphones. Those are purchasing within a particular period of time. They are going to get out of any of the 3. They are going to get 1. And as a owner of the IBM SPSS owner, I'm thinking that we are going to give for 50 people. I'm going to give you equal proportion. I'm expecting that we are going to get equal proportion in terms of the number of gifts that we are going to deliver. Now, after conducting the test, we are going to choose. Okay, for example, as a person who is buying this particular IBM SPSS, I have choices. Out of the 3, I have to opt for 1. Either it can be quick feel software, it can be pen drive, it can be headphones. Now, as a person who am buying it, I have my own choices. But as a SPSS IBM owner, you have your own expectations. You are expecting that we have 50 respondents, and out of 50 respondents, everybody is going to choose equally. Like, for example, when I talk about here equally, it comes around like roughly 17, 17, 17, right? Maybe 16, 17, 17, something like that. On average, we are expecting that we are going to have equal proportion. As a SPSS owner, we are expecting it. But what happened after completion of the study? This we are going to find out what is our observed values. Now, just look at our hypothesis. There are no significant differences in the preference of the type of subscription gift. Now, as an IBM SPSS owner, I'm framing my hypothesis saying that there are no significant differences in the preferences of the type of subscription gift. My alternative hypothesis, there are significant differences in the preference of the type of subscription gift. Okay, back to our data set. Go back to same data set, that is coding book 1. Here we have serial number 16. I hope my screen is visible to all of you. SPSS coding book
Yes, sir.
Yeah. Now, IBM SPSS owner gift to subscribers. We have 3 gifts: quick field software, pen drive, headphones. Okay. Now, in order to conduct a Chi-square goodness of fit test, go to analyze, non-parametric test. Please scroll it down. Please scroll your cursor down. You can see non-parametric test. Right side, we have legacy dialogues. As a part of non-parametric test, right side, we have legacy dialogues. Again, if you go to right side, we have Chi-square.
Yes, sir.
Okay. Yeah. Now here, Chi-square test. Here we have our test variable is IBM SPSS owner. Take this particular variable and keep it as a part of test variable. Okay. Now go to options. Select descriptives. Okay. Go to options. Select descriptives. Continue. Okay, that's all. You want me to repeat it? Is it clear? Coming to the outcome, we have 3 tables. One is descriptive statistics, basically providing the mean value. That is 1.48. Just leave this particular one. Coming to the main Chi-square test here, we have observed frequency and expected frequency. As a IBM SPSS owner, I'm expecting that on average, for every gift, we are going to have 14.7, 14.7, 14.7. But after completion of the data, as IBM SPSS owner, I realized that these are the preferences of my respondents. I mean, these are the preferences of my the subscribers, those who purchase IBM software. Majority of the respondents opted for quick field software, followed by pen drive, and very negligible proportion, there is very less number of people opted for headphones. And reason is very clear, right? We all know it's all about it. But as a part of subscription from IBM SPSS owner point of view, he was expecting that there should be equal proportion. There would be equal variance among the all the respondents, all the subscribers. But whereas results are different. Now, as you can see, residuals is nothing but 27 observed values minus expected. We have observed minus expected, that is residuals one can see here, right? Here 27 minus 14, that is 12.3. 13 minus 14.7, that is minus 1.7. Similarly, 4 minus 14.7, that is minus 10.7. Okay, this is all about Chi-square goodness of fit test. Now, coming to the test statistic, our p-value is less than 0.05. It means there is a significance difference between expected values as well as observed values. At the same time, we can also see that there are a lot of differences between subscribers. Majority of the people preferred quick field software than any other product. Okay, now coming to the data. Is it clear before going for the data interpretation part? Before looking at data interpretation template? You want me to repeat any of the table, any of the figure?
Yes, sir. Please.
Yeah, okay. The table below, the table that is given to the subscriber, provides the observed frequencies for each gift as well as expected frequencies, which are the frequencies expected if the null hypothesis is true. For example, if null hypothesis is true means observed frequencies and expected frequencies supposed to be same, equal. But if we look at our actual data, the differences between the observed and expected frequencies provided in the residual column. So these are the differences one can see. So there are differences between expected value as well as observed value. Both observed and expected values are not the same. Okay, next. Test of statistics. The table below test statistics provides the actual result of the Chi-square goodness of fit test. We can see from this table that our test statistics is statistically significant. That is, our p-value, as it is less than 0.05, there is a statistically significant difference. Okay. Second, therefore, we can reject the null hypothesis and conclude that there are statistically significant differences in the preferences of the type of sign, means the number of subscribers, those who opted for the particular gift. We can see there are differences in them in terms of their preferences. We can reject the null hypothesis and conclude that there are significant differences among the preferences of subscribers. Okay, and you can also write it quick wheel software, that is N27, as compared to either pen drive or headphones. It means they have opted more than any other product. Okay, so this is all about one-way ANOVA and chi-square test.